Okay, here we go. Homework on section 5.3. Number 7. Determine whether events E and F are independent. Independent just means one happening doesn't affect the other. So speeding on the interstate and being pulled over by a police officer, those are certainly not independent of each other. E and D and independent, if I can spell right. B. You gain weight and you eat fast food for dinner every night. Yeah, there's some sort of relationship there, so those are also not independent, which I know you can see dependent. I try not to use the word dependent because there is some sort of relationship, but it might not be that one actually depends on the other or causes. I feel like dependent means there's a cause and effect association, but not necessarily. Um, you get a high score on a statistics exam and the Boston Red Sox win a baseball game. Yeah, there's probably not an association there, so we'll say those are independent of each other. Number 9, suppose E and F are independent. F is, or probability of E is 0.3, F is 0.6. So if they're independent, we know that the probability of E and F is the probability of E times the probability of F given E. That's true always, but if they're independent, this simplifies to this. E times the probability of F. Because whether E happens or not, that doesn't affect the probability of F happening. So this would just be 0.3 times 0.6, which is 0.18, or 18%. Okay, this is the main thing to notice right here. If they're independent, you get this result. Okay, because E happening doesn't affect the probability of F. All right, 11. Flipping a coin, what's the probability of obtaining 5 heads in a row when flipping a fair coin? So probability of getting heads, 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 and heads. All right, well, that's probability of getting a heads times probability of getting heads, and they're all independent, so one doesn't affect the other. Heads 5 times, which is 1/2 times 1/2 times 1/2 to the 5th power, which is 1 over 32, which would be, percent-wise, 3.125%. And 13, southpaws make up 13% of the population. That's probably why they have 1 in 35 deaths in a classroom, right? Which is less than 13%. But anyway, another story. If two people are randomly selected, what's the probability that both are left-handed? Probably left-handed and left-handed. Well, we assume that they're independent events. So that's probability of left times the probability of left. In other words, one doesn't affect the other. So it's 0.13 times 0.13, which is 0.13 squared, which is 0.0169, or 1.69%. And then we have what's the probability that at least one is right-handed. At least one right hand. Well, at least one right hand, that means I could do left, right, oops, or right, left, or right, right. So I could figure out all those probabilities, but it's actually easier to do it this way. It's the complement. At least one right-handed is 1 minus the probability of both are left-handed. Because the complement of at least one right hand is 2 left-handers, which is 1 minus 0.0169, which is 100% minus 1.69, which is 98, 98 point, what would that be, 31%? Looks like. There we go. All right, let's do number 16 on this one too, since these are a little bit faster. Christmas lights are designed as series circuits. Drives me nuts because one goes out, the whole light goes, the whole line goes out. One light burns out, the entire string goes black. The probability of one bulb will last 2 years is 0.995. One lasts is 0.995. The success or failure of the bulbs independent of the others. What's the probability that a string of 100 lights, all 100 will last 2 years? So lasts and last and last 100 times. So we want all 100 to last. So that's the probability that they last times the probability that it lasts. 100 of them, which is 0.995 to the 100th power, right? And that's going to be 0.995. My calculator here on the side to the 100th power is 0.605605 or 60.6%. You know, let me show you how to do that on your calculator because I just realized some of you might not know that. So that's going to be, I got 200.995 raised to, that's his caret key, 100 power. Okay, so we got that. Cool. All right, and B, that was A. And then B is going to be, what's the probability that at least one will burn out in 2 years? At least one will burn out in 2 years. Well, that could be the first one, or the second one, or the third one, or the first two, or the first three, or the first and the last, or the middle. I mean, there's any combination, so that is a horrible problem to do. But if you recognize the complement of this is at least one burns out, that none burn out, well, that's just 1 minus none burn out. We did that up here, 0.6058, which is 100% minus 60.6%, which is 39.4%, if I round it off. Okay, so there you go, first through 16.